Thank you for joining this lesson. We're going to discuss intersecting circles, number 17. Remember to subscribe to this channel and to also share the link with friends. The diagram below shows two circles, center A and B, which intersect at P and Q. Then we are told that angle PAQ equals to 70 degrees, angle PBQ equals to 40 degrees, and PA equals to AQ, which is equal to 8 centimeters. So AP, AQ, this is 8 centimeters, 8 centimeters. Use the diagram to calculate part A, PQ to correct to 2 decimal places or correct to 2 decimal places. So PQ is the length at this point. Let me show it. PQ is the length. You can call it a chord because it's passing through given circles. That's the length PQ. We want to get its length. Allow me to start by making a line through A to B. So this line will help us analyze the question well. If the line is drawn horizontally, then we will have a right angle at this point. And if we assume that this point is M, then I can now work with a triangle APM, right angle at this point, 8, this is A, this is B, this is M. Now we can talk about, because we have bisected here, 35 degrees, 8 centimeters, so that we may get the length here, which I'm letting to be X. Therefore, I need to apply trigonometry now. Sine of angle 35 is given by opposite out of the hypotenuse. And this means for us to get X, then we need 8 sine 35 degrees. So this is going to be X is equivalent to, when we multiply this, we get 4.59. Then for us now to get PQ, we multiply 4.59 by 2, and this will give us exactly 9.18 to 2 decimal places, centimeters. PB, correct to 2 decimal places, length PB. So length PB is going to be this length, which you can let to be Y. We can apply again trigonometry, whereby we're going to work with an angle of 20 degrees. After this 40 has been bisected, now we will get a 20 at that point. So working with P, M, and B, then we want this length Y, then this angle will be 20 degrees. So we're going to say that, remember PM is known, PM is going to be length X, which is 8 sine 35. So the length here is 8 sine 35. So now I'll be talking about the sine of 20 degrees is given by opposite, which is 8 sine 35 divided by the hypotenuse, which is Y. So for us to remain with Y, then we need 8 sine 35 out of the sine of 20. This is going to give us exactly 13.42 centimeters. So that one has been obtained. Part C, area of the minor segment of the circle whose center is A. So the circle whose center is A, when we follow code PQ, then that circle will have this as the minor segment, and this is what we are going to calculate. So for us to get the area which I'm shading blue, then I'll need to take the whole sector APQ, then I subtract the triangle APQ. That way I'll get the minor segment which has been shaded. Therefore, I need the length or the area, sorry, the area of a sector. For me to get minor segment, then I need area of a sector, and I subtract area of a triangle. That will give me a minor segment. So I'm talking of theta over 360 pi r squared minus half AB sine theta. Half AB sine theta. Therefore, let me talk about now theta, which is a 70 over 360 pi, a radius of 8 times 8. Then we subtract half 8 times 8 sine of the angle between the two lengths, and this is going to give me exactly 9.04 square centimeters. So that is the area of the minor segment. I'll be talking about the area of the shaded region now. Area of the shaded region now will be area of the whole part APBQ. Then I subtract the unshaded part. So let me proceed to calculate the area of the other minor segment now for the circle with center B. That means I'll need to take the whole sector BPQ, then I subtract the triangle BPQ. So I'll be taking a theta, which is 40 over 360 pi r 13.42 is calculated up there squared. Then I subtract 13. Okay, we can start with half, the formula for the circle. For the triangle, that is 13.42 times 13.42 sine of the angle between them, which is 40. Therefore, when I compute this, I'm going to get exactly 5.01 square centimeters. So now with this is the first minor segment. This is now the second minor segment. With the two minor segments, we can subtract them from an area of the whole kite. Area of the whole kite. Therefore, I'll be talking of area of the first triangle plus area of the other triangle. Then I subtract area of the two minor segments, because the whole triangle plus the other triangle, we'll get the whole figure A. It's a kite in nature. So APBQ, it's a kite. So we need two triangles added. The first triangle is having area of 30.07. Triangle A, triangle, you can call it we name the triangle well. The first triangle, which is a APQ, is having area of 30.07 square centimeter. Then the next triangle, which is a BPQ, will be having area equivalent to, we said half, this is going to be 57.88. Sorry, I already calculated it. 57.88 square centimeters. So with the two triangles and the two minor segments inside here, we can get area of the shaded part, whereby total area now will be, we take 30.07, we add 57.88, then we subtract the two minor segments, which are having 5.01 and 9.04. These are the minor segments. Therefore, I'm going to get, let me work out once, 30.07 plus 57.88. Then now we subtract 14.05. 14.05, that is when we add the two triangles. This will give us 73.990 square centimeters. So this is going to be the area of the shaded part in these intersecting circles. Thank you so much for following. Subscribe and share.